Should you become a data scientist, data analyst, or a data engineer? If you're just entering the world of data, you have probably come across these three roles: data scientist, analyst, and data engineer. And yeah, I get it, they sound similar, and honestly, I was confused too when I first started. But here's the truth: each one is totally different and plays a unique role in the world of data. A data scientist works on prediction, machine learning, and advanced algorithm. A data analyst focuses on interpreting data, turning raw numbers into clear insight that help team make better decisions. And a data engineer builds the pipeline and system that move and process data. They make sure everything runs smoothly behind the scene. Now, if you love working with numbers, solving puzzle, or finding hidden pattern, great. But where should you actually start? Maybe you're excited by AI and ML. Data science might be your thing. If you're more into coding, building system, or enjoy backend development, that data engineer could be a better match. And if you enjoy visualizing data, making reports, and helping businesses make smart decisions, the analyst role might be perfect for you. Whenever you are in this decision making journey, just know this: you're not alone. Many beginners ask the same question, and the answer lies in understanding what each role it really involves and where your interest aligns. Choosing the wrong direction can slow you down or even make you feel lost later. That's why it's super important to understand what each of these roles looks like, what they do, what tools they use, and how do they help companies, especially in areas like marketing or business growth. Also, let's be real, tech is changing fast with AI, cloud computing, and automation on the rise. Some roles will be in high demands than others. So, if you're planning your career for 2025 and beyond, you need to know which role will actually help you stay relevant and ahead of the curve. That's exactly what we will cover in this video in the simplest way possible. By the end of this video, you will understand what each role means, which one fits for your interest, and which path can lead you to the strong future-proof career in data. Let's start with data science hierarchy, which is often visualized as pyramid. At the foundation of this pyramid, we have data engineer. Then comes data analyst, and sitting at the top are the data scientist. Let's start with the data engineer. So imagine a company running digital campaign across platforms like Facebook, Google, Ads, Instagram, and email newsletter. Each of these channels on which the ad is run generate tons of raw data: impression, clicks, conversion, bounce rate, and user behavior metrics. Now, all of this data comes in different format like JSON, CSV, or even unstructured log files, and from various sources like APIs, internal databases, third-party tools, and web analytics platform. Now, here comes the work of a data engineer who is responsible for gathering all this scattered, messy information and converting it into something structured and usable. Their job is to collect, clean, organize, and move raw data into a centralized location, which we call as databases like Google, BigQuery, Amazon Redshift, or Snowflake, making it easy for analysts and scientists to access and work with it. On a day-to-day basis, data engineers build and manage complex data pipeline using tools like Apache Airflow. They work with real-time live data streaming platforms like Apache Kafka to ensure that data flows in continuity. The programming language they use here is Python, SQL, or Scala. Perform robust data transformation to make raw input clean and structured. For large-scale operation, they rely on distributed computing system like Apache Spark or Hadoop. To become a strong data engineer, you will need to master several tools and technologies. You will need to know Python, SQL, Scala for coding. You will work with data warehouses like BigQuery, Redshift, and Snowflow, and use Apache Airflow or DBT to build ETL pipeline. For real-time or big data tasks, tools like Kafka, Spark, and Hadoop are essential. And since most of work happens in cloud, get comfortable with AWS, GCP, or Azure for storage and computing. Now the data has been collected, cleaned, and stored by data engineer. From here, data analysts will take over the second layer of pyramid. Their core job is to interpret the data, spot trends, uncover pattern, and deliver actionable insight. Continuing with our marketing example, once all the campaign data is centralized, the analyst steps in to answer important questions like which ad performed the best, which audience segment had the highest conversion rate, or what time of day got the most engagement. To do this, data analysts use tools like SQL for querying databases, Excel for organizing data, and visualization tools like Tableau or Power BI to create interactive dashboards and reports. They may also use Python libraries like Pandas for data manipulation and Matplotlib or Seaborn for plotting graph and visual trends. Their insights are crucial for marketing team, product manager, and executive to make data-driven decisions like where to increase ad spend, what type of content is resonating with user, or how to optimize landing pages. So we can say on a daily basis, data analysts write SQL queries to pull relevant data, clean and process data sets in Excel or Python, perform exploratory data analysis, EDA, RPA and build dashboard to track KPIs. They often meet with stakeholder to understand business question and translate them into data queries. To succeed as a data analyst, the essential toolkit includes Excel, SQL, Tableau, Power BI, Google Analytics, and basic Python scripting. Equally vital are the communication skill, as analysts act bridge between raw data and business team, helping transform numbers into decision. Once the data engineer has prepared the data and data analyst has uncovered key insights from it, the baton is passed to the data scientist. So at the very top of the data workflow sits the data scientist, often seen as the most advanced and specialized role in the data ecosystem. Unlike data analysts who explain what happened or data engineer who ensure the data is usable, data scientist focuses on predicting what will happen next. Their job is to apply machine learning models, statistical algorithm, and even AI techniques to forecast future trends, automate decision, and uncover complex relationship. So let's see a marketing campaign example once again. While the analyst identify which ad works best, the engineer made the data accessible, the data scientist might build a predictive model that estimates which user segments are likely to click on the next campaign, how likely a customer is to make a purchase within the next 7 days, or which customer or risk of unsubscribing. These insights allow companies to proactively target the right audience, reduce churn, and increase ROI. To achieve this, data scientists work extensively with tools like Python and R for data manipulation and modeling, and use powerful libraries like scikit-learn, TensorFlow, or PyTorch for building machine learning models. Their work requires a strong grasp of mathematics, especially probability, statistics, and linear algebra. On a day-to-day basis, a data scientist will gather training data, pre-process it, select features, experiment with different machine learning models, evaluate model performance using metrics like accuracy or precision recall, and tune hyperparameters to improve results. Once a model is working, they may also help deploy it into production or collaborate with engineers to integrate it into business system. So in short, data scientists are like the brain of the operation, pushing boundaries to bring predictive intelligence and automation into decision making. So if we look all the three roles together, we can see how they complement one another in smooth flow. In marketing and many other business functions, this workflow is what powers smarter campaign, better customer targeting, and ultimately stronger results. Now let's talk money, because being honest, it matters a lot. The pay scale for each role can vary based on the location, experience, company size, and your exact skill set. On an average, data analysts start with packages between 6 to 10 LPA. Data engineer often earn between 8 to 15 LPA, and data scientists can make anywhere between 10 to 25 plus LPA, especially if they have worked in top tech firms or have advanced degrees like a master's or PhD. Generally, the more specialized your skill set, the higher your potential salary, but that also means more learning and experience is required. So the big question is, which one you should choose in 2025? In 2025, all three, data engineer, data analyst, and data scientists, will continue to be in high demand. But recent trends show employers are now favoring hybrid professionals, those who can both analyze data and build infrastructures or model. This means someone who knows SQL and Python and understand machine learning concept is becoming a rare and valuable asset. So what's the best entry point in 2025? If you're just starting out and want a strong foundation, data analyst is often the smart choice. You can learn how to ask right question, explore real world data, and distill into stories without diving immediately into heavy engineering or deep math. From there, you can pivot based on what your real passion lies. If you discover that you love building the system that deliver data, transition toward data engineering. If you are drawn to algorithm, modeling, and AI, then push towards data science. So in conclusion, don't rush to call yourself a data scientist right away. Take time to explore all three roles, understand what excites you the most, and then build your skill in that direction. The data world isn't just one path. It's a ladder, and every steps count. Thank you, and see you in the next video.